Place the numbers 11 to 16 in the circles such that the sum of the three numbers on each side is 40. Can you explain the position of the odd and even numbers in your solution? And how might using Cuisenaire rods help you get to this solution and understand the structure of the problem more easily? Okay, so hopefully you've had a decent go at this task then, and maybe you come up with a solution. Be interested to know how you did it. The reason I really like it is because Cuisenaire rods really help get underneath the surface of the problem and reveal its structure. Because when you do build these six numbers, 11 to 16, hopefully it's really obvious that every single one of these numbers has something in common and that they all have a 10. So no matter where you place these numbers, every single one of the six circles will have a number which has a 10 and some units in as well. So what we can actually do is literally ignore all the 10s to begin with. So it's almost a bit like coding in statistics here. And then the problem now becomes, can we place these six numbers, 1 to 6, in the circles, such that the sum of the three numbers on each side is just 10? Because remember, every single one of the circles is going to have a 10, a 10, and a 10 in, which is 30 straight away. So we just need another 10 to get to that sum of 40. So we've simplified the problem quite a lot here, and we're probably in a position where we can just use trial and error here to arrange these rods and probably end up with 10 in each total without too much difficulty. But I like to shed a bit more light on this problem and think a bit more mathematically about it and think, okay, what about the properties of odd and even numbers? How could they help me get to the solution even easier? And think about what happens when you add three numbers together. Under what conditions do you get an even total? Because remember, we want a total of 10 in each row. So hopefully you've realised, okay, if I add three even numbers together, that's going to give me an even total. But unfortunately, 2 plus 4 plus 6 is 12. So what's the only other way of getting an even total? Adding three numbers together. We're going to need two odd numbers and then an even number added to it, because two odd numbers together will give me an even, and I'd need to add an even to that to make sure the total's even. So how does that help us then? Well, if we're saying we need two odd numbers and an even number in each of the sides of this triangle, and we've only got three odd numbers to play with, then the odd numbers must go in the vertices of the triangle. And luckily, because we can just rotate this triangle in any way we want, it doesn't matter where we place these odd numbers. They can go in any order that you want. It's still going to be possible to get a total of 10 on each side. Okay, so we've placed the odd numbers, and that has to be the case because I know that, say here, 3 plus 5 is an even total, 3 plus 1 is an even, and 5 plus 1 is an even. So all these are even totals at the moment, and I've only got even rods left to place. So now the answer is actually completely trivial. We just need to do our number bonds to 10. So here we've got 5 plus 1, which is 6. So the 4 rod must go in there. Here we've got 3 plus 1, which is 4. So I just need to place the 6 rod here. And then here I've got the 3 plus the 5, which is 8, and place the 2 rod here. So there's our solution. Each of the triangles now sum to 10. And then bringing back the 10 rods that we started with, we just know that every single one of these numbers has a 10 attached to it. So there is our solution.